Okay, an elastic particles question again here. So we've got a particle of mass 3m moving along a straight line. So let's draw a diagram. So there's our particle P. Sorry, it's not quite on the line there. And then we've got particle Q. Okay, we're given the coefficient of restitution, and we've got to show that the speed of Q is this. Okay, so we need an after diagram, so we know what's going on until the examiner can see how you've set up your problem and check your equations are correct. Okay, so we've got P and Q are going to collide. Now P is moving faster and is heavier, so we can have a guess that what's going to happen is this. Oops. Yep. Okay. So then when I've set it up, there's two things that we always look at with this. So we've got conservation of linear momentum, and we've got the coefficient of restitution. So our conservation of momentum, we have got before, I've got 3m times 2u. Now Q is moving in a different direction, so that's going to be 2m times u subtract, and that's going to be equal to, so now they're both moving in the same direction, so 3m velocity of P plus 2m velocity of Q. And then I can simplify that down. Okay, so there's my first equation. Then I'm also going to do coefficient of restitution, so that's E. So this is the speed of separation, so that's velocity of Q minus velocity of P, because they're moving in the same direction. Over the speed of approach, well, we can add 2u and u, because they are literally approaching each other. If we rearrange that, we can get that 3ue is velocity of Q minus velocity of P. So this is my second equation, but what I actually want to do with that one is I want to find the speed of Q. So I want to find velocity of Q in my equations. So simultaneous equations, I want to cancel out P. So I'm going to do that 1 times 3. Right, and then I'm going to write my other equation just here. So that was equation 1. And now my velocity of p's will cancel if I add those. So 9ue plus 4u equals 5 velocity of q. So then you should be able to see that you can rearrange that to get the answer that has been given. In order to show that, so you need to show you're working. Okay, so now they've given us the speed of P as well, and they want to find E. Well, so I knew that E was using my equation from here. Okay, so velocity of Q minus velocity of P divided by 3u. So then it's just a case of simplifying this. Again, that was to show that, so you're going to need to show some working. Right, so then they're going to add some information. So we've got something going on now. So now we're going to have a wall going on. So at point A, P and Q collide, and then after that, Q is going to go on and collide with this wall. Now when it does that, it's going to have its velocity, but we now know that E is a quarter. So if you sub that in, you can find out that that is 5/4u. Meanwhile, particle P is going to have moved along a bit, and we know that its speed was a half u, and we know that that is t. Okay, so we want to find out where P is once Q hits the wall. So for Q, well, there's actually no acceleration going on here. It's constant acceleration. It's none. So we can actually use just that speed equals distance over time. So for Q, our speed is always 5/4u. The distance it travels is d, and I'm trying to find the time. So I can get that time is 4d/5u. Now, what I want to know is how far has Q travelled in that time? Sorry, P travelled in that time. So if P's speed was a half u, we call the distance we want s. Time is 4d/5u. So therefore, you can just rearrange that and find that s is 2/5 d. Now, as you can see, that's not the answer we wanted, but that's because that's how far P has travelled towards the wall. So, P moves 2/5 d and is now 3/5 d from the wall. Okay, right. So, last situation, they're now going to add in what happens when we rebound from the wall. Okay, so we've now got P is going to carry on moving with a half u. Q is now rebounded. I'm just going to work that out in a second. And this want to find out. So at the moment, okay, when it started, P was 3/5 d from the wall, and what we want to know is where they collide. So I'm going to say the distance that they from the wall where they collide is going to be x, and this is when we get to point B, which is where they collide. Okay. Right, so what do we want to know? So Q and the wall we can look at. Well, we know if I call Q's velocity now W, so it says the coefficient of restitution is a fifth. Now, the wall obviously doesn't move, so the speed of separation is W, speed of approach is 5/4/u, so therefore I can find that W is a quarter u, so that's my speed after Q after it's rebounded off the wall. Right, then I can have a look at my two particles. So I've got P and Q. Well, when they collide, if we say they collide at time t, we can again use speed as distance over time. So speed is distance. Now Q, I've called that distance x over t. For P, speed is a half u. Now the distance it's going to move is 3/5 d minus x over t. Okay, so I've got two simultaneous equations and two unknowns. Different ways you can solve this. I use this to find that a quarter ut is x. Sub that into there. Then I could get what t was and what x was. But you can eventually solve them and get that x is a fifth d. Okay. And if you think about it, you could also work that out perhaps using some sort of common sense, because the speed of p is double that of the speed of q, so it's going to end up moving, if this is 3/5 d, that's going to move twice as far, so that's going to be 2/5 d, and that's going to be 1/5 d.